Welcome back to the channel. Watch the video until the end, leave a like, and subscribe to the channel to support us. Recently, Chinese scientists have made a curious discovery on the Moon, an unusual crystal. They also discovered that this crystal contains an element capable of replacing nuclear fuel. The composition of the Moon has long been a mystery to us. It's been almost half a century since the last Apollo mission, and since then, we haven't set foot on the Moon, making further direct studies more difficult. However, something has changed recently. In December 2020, China sent its Chang'e 5 probe to the Moon, a mission named after the ancient Chinese lunar deity Chang'e. The probe landed smoothly on the side of the Moon facing us and collected lunar soil samples for a few days before returning home with almost 2 kilograms of lunar rocks, including basalt, which is solidified lava. This operation represents a major feat, being the last sample of lunar soil collected in 1976. Lunar soil samples are also very important for understanding the history of our planet and have answered the question of how the Moon was formed. Thanks to lunar missions and ingenious computer simulations, we now know that the Moon was born when a wandering planetoid collided with a still young Earth billions of years ago. Fragments of our planet remained largely in Earth's orbit and, over time, coalesced together, forming the Moon. By studying the samples collected by their probe, Chinese scientists discovered a rare lunar crystal, which turned out to be the result of ancient volcanic activity, similar to some common garnets here on Earth. Moreover, these crystals indicate that there was volcanic activity on the Moon about 1.2 billion years ago. The composition of this material, never seen before on our planet, was confirmed by the International Mineralogical Association, and the crystal was named Chang'e 8, again in honor of the ancient Chinese deity. China thus became the third nation in history to discover a new lunar mineral not present on Earth. Among the other 140,000 soil fragments studied, scientists found traces of helium-3, a very rare isotope with potential applications as clean nuclear fuel, as it releases more energy than a normal nuclear fusion and does not pollute the atmosphere with dangerous radiation. Helium-3 is extremely rare on Earth but abundant on the Moon, probably due to exposure to solar winds. With just 25 tons of helium-3, we could produce enough energy to meet the entire energy needs of America for a year. It is estimated that there are more than 1 million tons of helium-3 on the Moon, enough to provide energy to Earth for centuries. In the future, helium-3 could represent a much more efficient fuel than current nuclear power plants, being a clean and safe fuel for the environment. However, collecting and using helium-3 would require advanced technologies yet to be developed. Returning to the Apollo missions, astronauts noticed that lunar dust had a peculiar smell and taste, similar to that of gunpowder. This phenomenon could be due to the reaction of lunar dust exposed to the ionized particles of the solar wind. The lunar surface is dotted with impact craters, but one in particular has caught the attention of scientists because it appears to be the entrance to a system of underground caves. This discovery suggests that there could be tunnel systems beneath the surface of the Moon, which could offer a safe haven for astronauts or serve as bases for future lunar colonies. The Moon does not have a significant atmosphere or a magnetic field to protect us from solar radiation, making living conditions extremely difficult. Astronauts can only survive on the Moon for a few days with current technologies. However, an underground tunnel could offer an ideal solution, similar to lava tunnels on Earth. In 1178, 5 witnesses in England reported seeing the Moon split in two, an event they described as accompanied by fire and flames. Modern scholars have linked this description to a lunar crater at least 22 kilometers wide, suggesting it could have been caused by the impact of a large asteroid. However, the absence of impact fragments on Earth and other evidence suggest that the crater could be much older than reported. Recently, traces of water and oxygen have been discovered on the Moon. Water may have been brought by asteroids that struck the lunar surface, while oxygen could come from molecules carried by the solar wind. These elements, albeit in very limited quantities, open new perspectives for exploration and habitability of the Moon. Interestingly, the Moon is rusting, a phenomenon that causes the appearance of slightly redder areas on its surface, similar to what gave Mars its characteristic red color. Earth's tides, influenced by the Moon's gravity, play a crucial role in marine ecosystems and global climate. Without the Moon, tides would be drastically reduced, causing profound impacts on coastal ecosystems and Earth's climate. The inclination of the Earth's axis, stabilized by lunar gravity, would be subject to greater variations without the Moon, potentially causing extreme climate changes. Finally, it's interesting to consider how life on Earth would be different if historical events, such as the extinction of the dinosaurs, had different outcomes. The disappearance of the dinosaurs cleared the way for the evolution of mammals and, eventually, humans. If the dinosaurs had not gone extinct, our planet would be very different, with ecosystems dominated by these creatures. Additionally, the myth that we use only 10% of our brain is false. In reality, we use almost all of our brain, but not all parts are active at the same time. This expanded view of our world and universe puts into perspective how much there is still to discover and understand, highlighting the importance of exploration and scientific curiosity.